Welcome to the recap video of our first topic, Internet Basics. In these recap videos, we are going to cover the most important concepts that we discuss in class. Keep in mind that we also have a more detailed written material on our class page, and make sure you're familiar with that, because that's pretty much what's expected from you to know. And these videos are here simply just for a little bit of help and to give you some more context and recap about what we covered here. So let's get started. So first concept that we covered is how can we connect computers and how the internet will just grow out of this concept of connecting two computers. So let me very quickly just sum up what we had. So here we go. If we want to connect two computers, that's relatively easy. We need a computer. We also need another computer. And we will need some kind of a wire, right, that can send information. So through which the computers can send information, like this. So that's pretty much enough for two computers to communicate. And we are good here. But as we are scaling, so what happens if we add a third computer, right? This is where things are getting interesting, because now we somehow need to identify these computers. So we must say that, okay, you are computer 1, and you are computer 2, and then you are computer 3. So we must come up with some ID. And in the internet, these will be the IP addresses. And we also need to connect them. So we can decide, for example, just to connect, let's say, computer 1 to all of the computers. And let's say we also have a fourth computer. And just connect it to computer 1 too. So to have computer 1 as a central hub, but then we somehow need to make sure that computer 1 cannot really intercept all the messages which should be exchanged, for example, between the computer 2 and computer 4. Or we can go and just try to connect all of the computers. But here you will see that this would give an exponential number of wires by adding a new computer. So it doesn't seem such a great solution, right? So the first concept is IP addresses, and we covered that. So IP addresses, at least what's called today IPv4, which is the most common IP address protocol used. It gives you 4 numbers. So every computer has a 4-number IP address. So for example, the CEU website's IP address is what you can see here on the screen. Each number here goes from 0 to 255, which is exactly 1 byte. So that's about IP addresses, and let's talk a bit about routers. So routers are here to solve the other problem, how we can interconnect multiple computers without laying out an exponential number of wires. And there is one router you've already seen for sure, and that's your home router, which looks like something like this, right, here on the screen. This router is a completely, fully functional first-class router. What does it do? You have multiple devices. You have your phone. You have your computer. You have perhaps some other IoT device or any smart home device like an Alexa. These will be all connected to your router, but now not through a wire, but through a Wi-Fi network. And your router would make sure that all the communication that needs to stay internal, for example, you try to share files through AirDrop on a Mac or through Windows sharing on a Windows, that the router will make sure that those requests and that data won't escape your home, but will be sent to the proper device. But all the data, for example, checking CEU's website, will just go out. And it will be passed to the router of your internet service provider. Probably your neighbor has exactly the same structure, so they have their own routers, and it's also connected to some central hub, which is perhaps in your street, and a few dozen devices, and a few dozen internet endpoints, so households are connected there. And then those routers are then just connected to even an even larger network of routers, which can then go to the your national central router hub, which is called the backbone. And then these are also connected to some more global or continental set of routers. And with that, you will go and we actually have a very nice structure of routers here. So let's take a look at this picture. It's really how it goes. You can start from here at the bottom. So we have area 1, which can be, let's say, your household and your street, and then this is connected to some more central routers, which goes to your national backbone, for example, and which is connected somehow to a global router, a set of global routers. Usually what you can see here also at the backbone, that that area has these 4 routers in the center, and those routers are interconnected not only a single way, but they have kind of a circle. So if they are losing any connection, then there is still another path to go between routers. So this whole topology is quite sophisticated, and also there are some special algorithms with which routers can decide how to send data and to which router to pass data if you want to get to a certain IP address. So that's the basic router structure. And then taking on a world scale, what you will see that there are providers, usually these are private companies, which have also submarine cables between continents, and they operate a set of global routers. So data can just flow between continents and globally. So it's a pretty sophisticated and also a pretty excited structure of how information can be sent. So that's about routers. Let's talk a bit about clients and servers, which is pretty easy. These are simply rows of computers. For example, if I'm sharing a file with you through, let's say, AirDrop, which is a Bluetooth-based protocol for sharing files on Mac devices, then you can say that one of my computer is a server because it serves the data, and then the other one is a client because it somehow accepts the data. But perhaps even a much better example would be classic web servers. So if you go to the CEU.edu website, it is actually hosted as a web server software with all the HTML files and the backend infrastructure on a computer somewhere in a server park. And that computer, it's really just like a super standard computer. It just looks a little bit different than yours, but it could be your laptop. So you could put your laptop into a server park. But these are what we usually say are servers. And then our laptops in such a setting are clients. So servers are what gives you a service, what provides you a service, and a client is what consumes a service. For example, a browser can be a classic client, and then a web server on the other part can be a classic example of a server. What you see here, these are the so-called blade servers. What you see on the screen, these computers, which are connected to the cables, you can see it pretty well if you take a look at the left. These are super standard computers. They are usually much stronger than your laptop and more expensive, but they run some OS, Windows or Linux or whatever. They don't have a monitor, so they just have some software running, and usually they run server softwares like a web server or an email server or an FTP server or anything like that, or let's say a cloud infrastructure, any kind of a cloud infrastructure. If this would be a server park of a cloud provider. Okay, so that's about servers and clients, and there are a few other things to discuss here. Just very briefly, that's already a pretty intermediate topic, but you will need to have a basic understanding of this concept TCP and UDP when we are moving on and configuring our cloud instances. Basically, there are two protocols out there in the classic internet world. One is TCP, the other is UDP. And protocol means the way of communication. So how computers pass information between each other. You can think about it as their own language. So TCP is a communication protocol which ensures that every little piece of data arrives. So let's imagine you download something from the internet. You got to use, and your browser will use, a TCP protocol for that because it wants to ensure that all the data arrives. So the TCP protocol goes something like this. It says, hey, give me this file, and this is what the client says, and the server just starts sending the file, and it will always just ask for a response, and the client will just send for a response. It says, yeah, the first chunk, I got it. Second chunk, I got it. And then let's say the fourth chunk arrives. Then the client will say, hey, where is the third chunk? And then the server said, oh, probably lost somewhere between the routers. So let me just resend it. So it's a constant communication between the client and the server to make sure that the information is complete and in a good form. So that's what you usually expect from the internet, right? So TCP is a very dominant protocol. The other protocol is UDP. The UDP protocol is a protocol that prioritizes time to delivery. That's great for example, a real-time video call, for example. Do you expect in a video call to have every byte of your sound and picture go through? No, that's not your main priority. Your main priority is to keep it real time, right? So just to go and just shoot the data, shoot my video, shoot my audio, and if there is a drop, perhaps a fraction of a second is missing, it's not a problem. We shouldn't then just stop and try to resend that. The show must go on. So UDP protocol is for that kind of communication. Here in this class, we will work mostly with TCP. Okay, so that's about TCP and UDP. And let me just show you a very quick example of the router system. So now you see my terminal. If you use a Linux or Mac-based system, you can easily recreate what I'm doing. But as discussed in the class, there is also ways to do that in Windows. And also, you are going to have access to cloud computers, which are Linux-based, so you will be able to recreate this. So for example, if I want to check how I'm getting from my home to CEU, I can use a command which is called traceroute. And I'm just giving it like the parameter ceu.edu. Let's see what happens. There you go. What you see on my screen is the actual path from my home to CEU. So you see neutronhub.home. This is my home router. This is the device that's in my living room. And then this is probably something near me, probably in my street, another router. And then as we are moving on, you see that we are getting closer to our Hungarian backbone, which will be H-bone, through some of these aorta routers. Now, aorta is a company name which is the mother company of UPC, which is my internet service provider. So these are some UPC routers. And then at one point, I'm hitting the Hungarian backbone, a set of routers, and extremely high speed internet connectivity. And then from that, I'm going to the CEU's internet, which must be in some kind of a server park. So this must be a router that leads to CEU. And then here we go with the CEU web server. It's called actually dev.ceu.hu. So you see that this is 9 hops, so to say. These are the routers I'm going to go to CEU. So it might seem that the CEU servers are in Hungary, and I'm in Hungary at the moment. So let's see what what happens if I go, let's say, and just say traceroute and something very American, let's say fbi.gov. There you go. Okay. I'm still starting with my Neutron hub. You see, I'm using pretty much the same routers to get to one of the main routers of UPC, and then I'm going to Telia. Telia is a Swedish company which is responsible to part of the global infrastructure. So also the submarine cables and many of these. So this is the place 7 and 8 when my internet package I'm sending goes through the ocean. And then here it is. This is probably the FBI's web server. Okay, so that's the routing infrastructure. Pretty exciting. Give it a go. All right, so let me come back here. Another thing we discussed is the domain name system, which means that we have our IP addresses, right? But what happens when I actually go and just put in like ceu.edu? How do I know which IP address that reflects to? And we discussed that there is a hierarchical system of so-called name servers where all of the domain names are registered and associated with an IP address. And that's the domain name system. If I switch back now, I can use this domain name system to just to look up any domain name. So for example, there is a command here called nslookup. If I say what's ceu.edu, it's pretty fast. It will just tell me, okay, this is the address. Okay, so this is about my address. Don't worry about that. But this is CEU's address. And also if I do the same, nslookup fbi.gov, you see that these are the two addresses actually. So they have two addresses. This goes beyond the scope of what we are covering here. But you see that we have a simple tool with which we can use the domain name system. Okay, so this way, actually when I do a traceroute, the very first operation that's going to happen is that my computer figures out the IP address of CEU and then it starts connecting to it, right? So the name resolution, so to say, is always it always comes first. All right. So let's discuss a bit about ports. Ports are super important. You don't need to know them in order to get along with internet, but if you do anything engineering on the internet, it's a very, very basic concept. You can think about ports as ports on your computer, like you have perhaps a port for your monitor, like an HDMI port. You have several USB ports or USB-C ports. You have a port for electricity. You might have a port for audio, and so on. So ports are different endpoints which serve different purposes. Here, in the internet setting, a port is really a number. So this number can go to 1 to up to probably 65,000 if I recall correctly. And you can think about these ports really just like little doors on a server. So for example, if it's a web server, then the web server by consensus listens on port 80, so 80. So if your browser wants to connect your web server to HTTP, it will just send a message to this web server, and in the message it will tell that, hey, I'm sending this message to port 80. And on the server, there will be port 80 open, so to say. So it's accepting requests on port 80. and your message can just go right in. But if your browser for whatever reason would try to send a message to port 85 and not 80, then probably it wouldn't get an answer. Actually, I can show this to you. Let me just open this up. So if I say CEU.edu and on port 80, this is how you do that. Let me just switch in 1 sec. There we go. So CEU.edu port 80. You see, I'm in. This is the CEU website. But if I say CEU.edu and I want to connect to port 88, it says, hey, this site cannot be reached because the connection is refused. So nothing expects requests on port 88. All right? So that's how it works. And there are some ports are there by consensus, like port 80 for web, port 443 for secured web connections. This is where you connect to if you use HTTPS. There is, let's say, port 25 for sending email, and also for FTP, that's, I believe, 22. So there are a few standard ports. And you can also create your own, of course. If you want to go to the deep web, so to say, you can just set up a web server which listens on port 1234. And probably no one will try to connect there, but for those who know that your web server listens on that port, it will be able to use your services. So that's about ports. And I can also show this to you here in a terminal, that if I go and just check out, for example, with a command called telnet, c.edu, I try to go at 88, it says connection refused, okay? But if I say 80, it gets connected. It says, hey, okay, what do you want? This is what the server says. And I just say, for example, hello. Okay, and this is the server's answer. It says, bad request. I have no idea what you're talking about. This is a web server. It cannot interpret hello. So even though you said hello, it, cannot be understood. So this takes us to our next topic, which is the HTTP protocol. And the HTTP protocol is exactly what you saw here on my screen. If you connect to a web server, then you need to talk the language of a web server. So what you could do with HTTP, and I will give you an example, is just say, instead of hello, you would say like, hey, HTTP 11, get this website's HTML code, and then you would get it. So this is another level of protocols when you can make a connection to IP and TCP. So you identify the connection. You actually before that you get the DNS to work, right? So you get the DNS, you identify the computer, you connect to a certain port through TCP, so no data will get lost. And then if you know that this is a web server, for example, you can start talking the HTTP protocol because that's the language of a web server. And with HTTP, you can communicate with it. So let me show you an example now. So there it is. Let me go to the CEU website. If you use Chrome, you will have a so-called developer tools, which is on a Mac, is here in the view menu, as you can see. And there you can just check what's going on. So for example, here is a network. It's empty. Let me refresh to see what's going on if I connect to CEU.edu. There we go. Okay. So you see that it's a bunch of connections and actually a bunch of files that are getting. So there will be some JPEGs and some special codes. But what matters for us here is that there is also the very first request. This is what we need to know now. The very first request. And let's take a look at the request itself. So if I go to the request headers, view source, this is exactly what my computer just told CEU. So when my browser connected to CEU on on this port. I believe this is now an HTTPS connection, right? There you go. So it's not port 80, but 353. Then it would say, hey, I'm speaking the 1.1 version of HTTP, and get me the www.ceu.edu. And then some other information our browser says. It says that, hey, I am actually a Chrome computer. You see it here. It runs on a Macintosh, and this is my OS, and many other things. And for example, it also says, hey, my preferred languages are English, UK or US, I don't care. And then this is what the computer says with view source. It says, so this is what the server says. It says, hey, HTTP 11200 okay, it means 200 means okay. This is my date, and here are some of the properties what you need to know about me, the server, what you can do, and so on, what kind of content I'm sending. This means you are going to receive an HTML page, and if I take a look at the response, then this would come later, the HTML page itself. So this is the website, right? For example, if you take a look at the title, you would see it says Central European University. That's exactly what you see up here. So if you change this somehow on a server, this little piece of information will be changed. And then, of course, the rest is pretty sophisticated because it's generated by some content management framework system. So that's HTTP. And this pretty much concludes the basics of internet. For more information, check out the course website where we put pretty detailed information about what you need to know and what you need to understand in order to be successful later when we are covering in our next classes digital signatures and HTTPS and general encryption, and then later cloud infrastructures and cloud computing. So thanks for checking this video, and I'll see you in our next recap video about encryption and digital signatures.